Hello students, we are going to discuss today zeolite method. Since we are talking about zeolite method, our objective will be learning together about water softening. Water softening, in previous lecture we have learned about what is making water hard and why it is a matter of concern. So the outline of today's lecture becomes to understand how water can be softened. In previous lecture, whatever we have learned, that the question comes, what minerals primarily contribute to hardness? We have four options: calcium, magnesium, carbonate, bicarbonate, sulfates, nitrates and chlorides of calcium and magnesium. So the answer becomes all of the above. From the above answer, we can see groundwater dissolves rocks and minerals, releasing calcium, magnesium and other ions that cause the water to be hard. This is these dissolved ions which makes the water hard. Now, why softening is important? Because when we use hard water in various apparatuses like geyser or boilers or washing machines or dishwashers, then they consume more detergent, more electricity because there is a formation of scale and sludge. So when we use soft water in washing machines, dishwashers, water heaters, etc., then the use of detergent is lessened by 50% and we can save energy and troubles also. Now, when we have learned about softening, then there must be various methods which are popular for softening. Out of these methods, the most popular methods are lime soda, ion exchange, zeolite, three methods. In this lecture, we are going to study about zeolite method. How does a zeolite softener work? Before we go to learn about the working of zeolite, we need to know what zeolite is. Zeolite is a hydrated sodium aluminosilicate. It is also known as permitted green sand and boiling stone. This particular sentence is underlined because you need to remember what are the other names or synonyms of zeolite. It is capable of exchanging reversibly its sodium ions for hardness producing ions. We have already learned about the hardness producing ions, and our motto is to remove that calcium and magnesium ions, and zeolite has a capability to remove the calcium and magnesium ions in place of sodium ions, which is the active site of zeolite. The general formula of zeolite is Na2O, L2O3, X SiO2, Y H2O, where X can be ranging from 2 to 10 and Y from 2 to 6. That means the molecules of silicon dioxide SiO2 may be from 2 to 10 and that of water may be 2 to 6. Zeolites are of two types. They can be natural, they can be synthetic. Natural zeolite have one property of non-porosity, whereas the synthetic zeolites, which are prepared together by heating china clay, feldspar and soda ash, they have the property of porosity and they possess a structure which has more exchanging capacity. If we need to understand broadly how the hardness is removed from the water by using zeolite, it can be explained by a figure which is shown here in the slide. These are the calcium and magnesium ions in untreated water, and these are with black dots. They are the active sites of zeolite, and this calcium and magnesium are replaced by these sodium ions. So, in treated water, the sodium ions come as exhaust. What is the reaction, theory or principle? The question in examination may appear as explain the reactions, explain the theory or the principle behind the zeolite method. So, we have to learn a topic with all the synonyms. The basic reaction behind zeolite method is we have written zeolite as Na2Ze, where the active site is Na2 and the remaining molecule is represented as zeolite Ze. When the calcium bicarbonate hardness is combined with zeolite bed, then it replaces the sodium ions and we receive calcium Ze or magnesium Ze, whatever is the salt present in hard water. It may be calcium chloride, it may be magnesium chloride, calcium sulfate or magnesium sulfate or some other also. So correspondingly we get sodium chloride, sodium bicarbonate, sodium sulfate. This depends on what type of salt is present in the hard water. How the process is followed? For softening of water, hard water is percolated at the specified rate which is kept through the zeolite which is kept in a cylinder. The water containing calcium and magnesium ions are retained by zeolite as calcium zeolite and magnesium zeolite, whereas the outgoing water comes as sodium salt. This is the pictorial presentation of zeolite bed. This is a line diagram where a vertical cylinder is made. At the lowermost end there is a layer of gravel which is placed on a wire mesh. This gravel, it doesn't have any function, it just supports the zeolite bed. Zeolite bed is placed, the granules of zeolite are placed over the gravel bed and from here the hard water is passed. The hard water moves through the zeolite bed and from the lower end of the tank we get the soft water as outlet. Here this process is for NaCl which will be explained in the coming slides. Now we can understand how the water softener works, that means how the zeolite works. For example, we have taken this presentation as sodium zeolite. The yellow colored granules are sodium zeolite. Now in the second portion, when the hard water enters, it is containing red colored particles, that means calcium and magnesium ions. Calcium and magnesium ions once are moved towards the zeolite, then the replacement takes place and the sodium ions are replaced by calcium or magnesium ions. When many gallons of water is passed through the zeolite bed, then the zeolite becomes slowly exhausting. At this stage, the third stage, it is partially exhausted but still delivering 100% soft water because still the zeolite granules are having active sodium states. Now when we have all the active sodium sites completely finished from the zeolite granular bed, then the regeneration is required. How regeneration is done? By the NaCl bed. What is regeneration? When the zeolite bed is completely converted into calcium or magnesium zeolite, then it stops to soft water. This stage is called exhausted zeolite bed. At this stage, we have to stop the supply of hard water because now you won't get the soft water as outlet. It can be checked by any method, any simple method that now the zeolite bed has started the eliminating the hard water. Now here comes the role of computer science students as well as electronics students. Up till now there is no such sensor developed which can detect that the hard water is completely stopped becoming soft. So you can place a sensor here where it will detect that hardness has been stopped coming out of the water and now the zeolite bed is exhausted. So a software operated zeolite bed or zeolite tank can be manufactured which will represent that now the process needs regeneration. Regeneration is done by using 10% brine solution, that is NaCl solution, which when reacts with calcium zeolite or magnesium zeolite, it converts again back to its previous original state, that is Na2Ze, and the hardness producing substances like calcium chloride or magnesium chloride are eliminated back. This can be explained by a pictorial presentation, like we are reversing the cycle. This is red granular zeolite which is containing hardness in exchange of sodium. Now salt brine, which is most economical, this is added from the lower end. Slowly all the active sites are again regenerated and the excess salt is also removed. A situation comes which is represented by 8th stage, that is the regeneration is completed. Now the zeolite bed is again ready for softening of new batch of water. The washings will now contain calcium chloride, magnesium chloride, which are led to drain, and the regenerated zeolite bed thus obtained is used for softening purpose again. Now in the next lecture we will learn about the merits and demerits and how to calculate the hardness based on zeolite method. By this lecture, after learning this lecture, you can answer these questions. You must be able to answer these questions. What are the synonyms of zeolite? We have learned that permuted, boiling stone method, green sand method, these are the synonyms. Which substance is used to regenerate a zeolite bed? What it is commonly called? The answer is NaCl. So, students, thank you.